Okay, good. Now we're recording. All right, let me share the slides. And everything I'm going to show here is already on Sakai. So hopefully this will be pretty easy for everyone to follow along. Um, so to those who will be watching this video later, thank you very much for coming. I know that it's been really trying times to figure out how we're going to do all of our classes here. So hopefully this will work out pretty well over the next few weeks. What I'm going to try to do today is start off by showing some slides. If this doesn't really work, then we can go back to trying to write things on like a virtual whiteboard. But at least for today, I want to see if we can try things out with some slides here to see how all of this goes. So the plan for today really is just to use this as a test. What we're going to do is just go over some preliminaries of how we're going to do the rest of the course. So talk about how this disruption is really going to move things around in terms of like the schedule for the homework assignments and the final presentations. And then I just want to do a recap of what we did before the break. So this is really the Wednesday, March 11th and the Friday, March 13th. So let me see. Looks like Josh is signed in here.
Hello.
Hi, yeah, good morning.
Morning. Yeah, there was some like issue with the like the whole Zoom thing. I don't know what happened. It just like wasn't letting me in for some reason.
Okay, well, I know that I have things set up so that whenever anyone logs in, you have to go to a waiting room first, and then I admit
Ah,
from the waiting room.
okay, I see, I see.
So yeah, so as soon as you enter the waiting room, then I can click admit. That's what I do now. Yeah, but can you see the screen okay?
Yeah,
Okay, all right, great.
should be able to.
Okay, yeah, so all of this is being recorded, and I'll just put the video online when we're all done. I don't expect this class to be very long today. I really just wanted to set things up as a test just to see how everything's going to work.
Perfect.
So as I was saying, really a lot of what we're going to do today is just a recap of what we did the last few days before the break. So no new material today. This is all supposed to be a test just to make sure everyone is able to work with Zoom just fine. So let me just start by saying a little bit about how we're going to do the rest of the course here. So of course, everything will be online instruction for the rest of the semester. Hi, good morning. Yep, we've already started class here, so I'm just going over the slides. Hopefully you can see everybody here on the screen. So of course, we'll have class at the same time as usual. It'll just be Monday, Wednesday, Fridays from 9 to 10 Pacific time. If you're not able to make it to class, that's perfectly fine. We're just going to have all of the videos over Sakai. But you have noticed that you do need to register in order to sign in for the videos here. This is just to make sure that we don't get any weird kind of people coming in messing up the class one way or the other. I'll probably also broadcast this over either YouTube or Facebook if there really isn't any interest. But again, today is just a test to see how all of this is going to go. I am going to have office hours at the usual time. So this will be 11 a.m. in the morning and then 4 p.m. in the afternoon. It'll also be over Sakai. In this case, you don't have to be registered to log in. Just click on the links and I'll just be here during those hours. So any questions that you have, just feel free to drop in. And of course, if you aren't able to make any of these times, just send me an email and then we can also set up some other times to meet for office hours. The due dates for the homework assignments have all been pushed back a couple of weeks. What I'm going to ask is that you upload everything to Sakai. So let me kind of pull out here and go here to a web browser, and then you can see what I mean. So here I have Sakai pulled up. And if you go over here, let's say to Dropbox, see somebody else is signed in. All right, if you come over here to the Dropbox section of Sakai, then you'll see that there is a place where you can come in here and then just start to upload documents. You can upload files in this way. So what I'll just ask is that for all of the homework assignments for the rest of the course, just go here into Sakai, upload the documents here. I know that you had homework assignment number 4 that you submitted before we took off for spring break. I'm going to grade those and then upload those here into Sakai. So you'll be able to see all of the assignments right here. So I'm hoping that this will work. I have no idea how well this will work. I've been having a little bit of trouble with Sakai and Dropbox myself. But if you have any issues, just send me an email and hopefully this will work out. Right. Okay, let me come back over here. Okay. So you have any questions for me so far? Okay, great. So here's the new homework schedule in terms of all of the dates and all of the times. The next homework assignments are going to be due the next 2 Fridays. So officially homework set number 5 will be due this coming Friday, and homework set number 6 will be due the Friday after that. Feel free to upload it into Sakai whenever you want. So if you're ready to submit it today, that's great. If you need a couple of extra days because Sakai is giving you trouble, that's fine too. No worries, no big deal. I did decide to cancel homework sets 11 and 12 because we just won't have the time in terms of how we're going to do all of this. So really there's just going to be 5, 6 more homework assignments as the semester progresses. In terms of the final presentations, we're going to move things over to do video presentations. And I know that you all are in different time zones, so you can either choose to do a live video presentation or you can just record a video and then we'll maybe show it here as part of class. But we can talk about this later. I'm not really so worried about how we're going to do the final presentations, but I still would like to attempt to do these. So hopefully we'll get this worked out as the semester progresses. Right. So let's start then with the content. I want to do a recap of what we talked about Wednesday, March 11th. So this was the Wednesday before we broke for spring break. As usual, let's let F be a field where the characteristic is neither 2 nor 3, and we'll fix an element lowercase k in our field, and we want to consider this quartic curve, this y squared is equal to 1 minus x squared, 1 minus k squared x squared. So there were 2 main things that we discussed that Wednesday. First is, if we do the naive thing and take our quartic curve, this here, and maybe try our best to homogenize it by doing something like this here, then we actually find that we have a singular point. So that is the point at infinity will be a singular point. So in some sense, we don't really want to do this naive thing of embedding into P2. Instead, let's try to embed everything into P3. So now we'll do this trick here of introducing, say, more coordinates. So x0, 1, 2, 3. So we're embedding everything inside of P3. Now we have 2 equations. And this will give us, instead of 1 point at infinity, it will have 2 points at infinity. Right? That was the main thing that we found before. So for today, I want to focus on the question of what happens when we try to introduce elliptic curves. So of course, we know that we can write down very clever substitutions. Let's say when we're dealing here with our quartic curve, and we can write everything so that we have a nice cubic curve here, right? So this was our elliptic curve where capital A, capital B, we can write in terms of this lowercase k. And we actually found that for this cubic curve that one of our affine points, so this was maybe x equals 1, y equals 0, that will correspond to the point at infinity on the elliptic curve. And then these 2 so-called points at infinity on the quartic curve, right, again embedding inside of P3, should correspond to these 2 affine points on the elliptic curve. And so simply put, making all of these substitutions allows us to say that our quartic curve really is a non-singular curve if and only if k is different from -1, 0, +1. So again, the whole point here is that if you embed everything into P2, you run into problems. But if you embed everything into P3, now everything is very nice. You can actually think of this thing as a non-singular curve, and there's substitutions you can make to turn it into an elliptic curve. Okay, okay, so everything okay so far? Okay, great. So again, the goal for today is to try to do all of this now in complete generality. So let's set things up in the following way. So we've worked out properties with this quartic curve. And again, we're going to fix characteristic different from 2 and 3. And let's try to consider this slightly more general case, this y squared is equal to f of x, where f of x will be a quartic polynomial. So what I want to do is consider first a proposition that allows us to do exactly what we did before. So we're going to take our curve and try to embed everything into P3. So the first part of the proposition says that if we just do the naive thing and embed everything into P2, so this is in general, now if you're given any degree 4 polynomial, right? So not just our y squared is equal to 1 minus x squared, 1 minus k squared x squared, but any degree 4 polynomial, then the point at infinity is always a singular point. So again, the whole thing is that if you do the naive thing and embed everything into P2, you run into a problem again. So we're not going to do that. So the question is, what happens if we embed everything into P3? So again, we'll do the same trick as before, right? Let's consider this clever substitution of introducing more variables. Then just like before, we should have an intersection that corresponds to two equations. And those two, we can write in terms of these two degree 2 polynomials here. And just like before, we expect to find 2 points at infinity. There's a subtlety now, though. Now we have to work over the algebraic closure. This is because we're going to have to take a square root, right? So I'm going to come back and say a few more facts about this, but kind of by going over some specific examples. So again, if you just embed everything into P2, then you run into trouble. But if you try to embed everything into P3, then you have 2 points. And this corresponds to taking the square root of the leading coefficient. This is the square root of A4. So simply put, you have 2 points at infinity if and only if A4 is a perfect square. Right? So here's some examples. So if we come back to our familiar curve, right? So this is this y squared is equal to 1 minus x squared, 1 minus k squared x squared. We again have 2 points at infinity because the leading coefficient is a perfect square. Right? So this is exactly what we've been finding. If instead now we consider this slightly different example, so y squared is equal to 1 minus x to the fourth, we again find 2 points at infinity because the leading coefficient is a perfect square. And in this case, the 2 points will correspond to these here, of course, sitting inside of P3. If instead now we consider this quartic curve, so y squared is equal to 1 minus x to the fourth, we do not have points at infinity because the leading coefficient here, at least over the rational numbers, is not a perfect square. Of course, we could work over the complex numbers and we would actually find points at infinity. So for example, here, the 2 points at infinity will correspond to plus or minus I. But if you're working over the rational numbers, you don't expect to find points at infinity. So this is what I was mentioning before about you have to work over the algebraic closure to do all of this. So all of this is just simply saying that here's the idea about looking at points at infinity now. Okay. So I want to go over the proof of the proposition here. So this whole thing of that we have a singular point at infinity, and then we have this intersection of these two quadratic polynomials if we're working inside of P3. So let's start off by proving the first one, that we actually have singular points. So again, we're just going to try to do the naive thing of, say, embed everything into P2 by simply doing this here. And of course, that really comes down to looking here at this homogeneous quartic, right? So this homogeneous polynomial of degree 4. So we want to prove that our so-called point at infinity is a singular point. So all we have to do is just consider partial derivatives. So we have here our polynomial of degree 4. We'll just take partial derivatives here. So partial with respect to x1, x2, and x0. And when we do all of that, we can then substitute in the so-called point at infinity. So remember that x1 is 0, x2 is 1, and x0 is 0. So when we do that, you can see that the three different partials here, partial with respect to x1, goes to 0 because x1 is 0 and x0 is 0. Partial with respect to x2 is 0 because, again, x0 is 0. And partial with respect to x0 is 0 because x0 is 0, x1 is 0. Right? So putting all of that together, then we know that our so-called point at infinity is a singular point because, again, all three of the partial derivatives vanish. So now let's try to prove the second part of the proposition. So this was the whole thing of what happens when we try to embed everything into P3. So let's make a definition here. Let's consider these two homogeneous quadratic polynomials. So these are two polynomials that have degree 2. So I'm going to consider now two cases. So why is it that this actually looks like this quartic curve, this y squared is equal to f of x, where f of x was this degree 4 polynomial? So let's start with the case of setting x0 equals to 0. So I want to ask, what are the points now that are these simultaneous zeros for these two degree 2 polynomials? Well, if x0 is 0, then let's say we want to set f1 equal to 0. So for this to be equal to 0, if x0 is 0, then of course that means that x1 has to be 0. So that's exactly the statement here. Right, so again, if x0 is 0, the only way that f1 is 0 is when both x1, x, and x0 vanish. Now, on the other hand, let's try to ask, what if f2 were equal to 0? Well, for this to be 0, I already know that x0 is 0 and x1 is 0. So the only thing that's left here would be really this part. Right, so again, if x1 and x0 are 0, I want f2 to be 0. So then that means we have to have this condition here. Right, so x2 squared has to equal the x4, x3 squared. So now you can simply solve for x1 and x3. Remember that we have to stay away from the origin. So this has to be the only point. Right, so again, if x0 is equal to 0, these are the only 2 points when both f1 and f2 are equal to 0. Right, so this kind of corresponds to what we mean by the 2 points at infinity. Now, what about the other case where maybe x0 does not equal to 0? So again, I want to ask what happens when I set f1 and f2 equal to 0. So if we assume that f1 is 0, then we're going to make a substitution here. So let's first maybe define x as this, and we'll define y as this. So then, of course, because f1 is 0, then this means that x3 over x0 has to be x squared. Right? So here are my three variables, x1, x2, and x3, all in terms of x and y. So now what we'll do is we'll ask, when does f2 vanish? So let's take f2 here, and let's maybe divide this by x0 squared. Right, so again, I'll take f2 divided by x0 squared. I'm assuming that x0 does not equal to 0, so we can do this. So first we have this here, which of course is just y squared. And then we have some of these other terms. So of course, when I see an x3, then remember that this is just the same thing as x squared. Right, so this is where I have these terms here. And of course, when I see an x1, then that's just x. So we have these terms here. Of course, I have x squared times x. So that's where x cubed comes from. So the point is that if I take f2 and divide that by x0 squared, then I actually see exactly the degree 4 polynomial that we were dealing with in terms of just x and y. So we can conclude by saying that f2 vanishes if and only if y squared is equal to f of x. Right? So again, the whole point here is that if we take a look at when x0 is equal to 0, then we find our 2 points at infinity. But if we look at the case where x0 does not equal to 0, then we find the affine part of our curve. Right? Okay, so let's just try to recap and put everything into one place here. So again, let's take a look at our y squared is equal to f of x, where our f of x now is an arbitrary degree for a polynomial. So it can be anything that we want. So the first part of the proposition says that if we embed this into P2, that's a problem because we always find a singular point. Right, so simply put, whenever you're dealing with a degree 4 polynomial, you don't want to embed into P2. Right, if we had a degree 3 polynomial, we were fine, but for a degree 4, that's not really the right place to do it. On the other hand, if we do embed into P3, then we actually can find a curve, but now we have these two polynomials. Right, so f of 1 and f2, both of these here have degree 2, and we actually do find that we have 2 points at infinity. Right, of course, they depend upon the leading coefficient a4, whether or not it's a perfect square. So what I want to leave you with is this question of, we know that if we're dealing with everything inside of P2, then we have a singular point. But you notice that I didn't say anything about whether you have singular points if you sit inside of P3. So what we're going to do on Wednesday is focus on this whole question of, when do we actually have a non-singular curve? So when do we actually know that in general, we can express this y squared is equal to f of x as an elliptic curve? So that's going to be the goal for next time. Okay, so like I said, I wanted to just kind of end a little bit early today. This is really just supposed to be a test to see if everything is working just fine. So you have any questions, comments then before we call it a day here? Okay. All right. Well, as I said before, all of the slides should be online. So hopefully you'll be able to see everything there. I also do have all of the lecture notes online as well. So hopefully that won't be an issue. And just remember that the next homework assignment is going to be due on Friday. So the plan is just to upload everything into Sakai. I would say go ahead and try to play around with it now. If you do have any trouble, just let me know, and then hopefully we can get it worked out. Right. Okay, well, thanks all. Thank you all very much then. So you all have a good rest of the day and try to get some sleep. Okay, see you later.
See you.
Thank you.
Bye.
See you.